So my name is Anish. I am co-founder, CTO, and the Chief Scientist for Panther Protocol, not Pantera. Sorry, apologies. And so I've had some interest in various things, including ML and privacy-preserving ML and ZK, among other things. Okay, why don't you, please?
Hey everyone, I'm Ben, co-founder of Gensyn. We're building the network for machine intelligence. Most people know us for the compute protocol that we build that connects up machine learning capable compute hardware in a unlimited size network and allows machine learning engineers, researchers, etc. to essentially train a model without having to think about the hardware. They can just submit the model to the network and the model will train on any kind of subset of the world's compute devices without having to book time on a device through Amazon or Google or one of these kind of cloud platforms. The idea is commoditize compute and just give people direct access to machine learning operations on devices without thinking about the devices. And prior to Gensyn, my background's in machine learning research.
My name is Greg. I'm the CEO for Overclock Labs and a core contributor to Akash Network. Akash is the world's first decentralized supercloud. Supercloud, like the name suggests, is a cloud that federates any cloud-capable compute, be it a private or a public cluster, and brings that in a permissionless in a peer-to-peer manner, where users can effectively access compute using a marketplace mechanism at significantly lower cost, usually 80% cheaper than what you would normally otherwise pay on a traditional cloud. And more importantly, access to resources that are extremely hard to get, like accelerated compute, be it H100s or A100s. Akash is also a widely used protocol. One of the biggest users for Akash is NVIDIA, and Akash is directly integrated into NVIDIA products. And several other users include universities to decentralize AI applications, be it Venice and whatnot.
So thank you both. That was very interesting to have people who quite know what it is that they're talking about. So let's get into it. So I had a few questions which I shared with you. The idea is look at things as a broad level, and depending upon how comfortable you are and the audience is, go into as much as detail as you want. So if you were to talk about any amount of decentralization, the key challenges typically is inference through compute, right? So I would like to start the conversation with that, and share your thoughts. What do you think are the immediate blockers, short-term, medium-term? What do you think would be the solutions that you think that are? What are the common trends that you see?
Yeah, so I think from our side, we think very kind of like from first principles about the tech behind machine learning, and then we think about what does decentralization do? What does it unlock for the kind of machine learning world specifically? And that's how we kind of came to crypto as a world, as a company. The background of the founders, myself and my co-founder Harry, are in machine learning, not in the crypto space. But when we set out to build Gensyn, we set out to build the largest scale infrastructure we possibly could. And when you do that, you hit this barrier of trust, essentially, where if you want to connect up theoretically all of the compute in the world and all of the compute that could exist in the world in the future, you want to be able to seamlessly execute things on that compute, but you can't do that without trusting the owners of the compute. If you're kind of financializing, if you're providing payments for doing some work in that situation, people are incentivized to lie, basically. Like if somebody can do 50% of the work and get 100% of the payment, you assume they probably will do that unless they're caught. And so we looked at that and said, well, how do you solve that? In the normal centralized kind of traditional world, you would put a company in the middle, the company would KYC everybody, and then they would kind of have contracts with them. If you break the contract, then you're liable for some payment or something like that. But that doesn't scale. It's really expensive. It's expensive in terms of money, but also in like time and human cost, just doing all of that work. And it puts a ceiling on the size of network that you can build, and we didn't want that. We wanted to build a network that could just be unlimited kind of scalability. And so for us, decentralization presented itself as this kind of solution. If you can have decision-making over decentralized nodes, i.e. if I run the software and I connect up to somebody else who's running the software and a bunch of people get together and do that, can we make decisions collectively? And it turns out, yes, you can with blockchain as a technology and with kind of decentralized consensus. And so to us, that's the biggest unlock here for machine learning, is just that ability ability to make decentralized decision making and establish trust over an untrusted group of kind of any number of devices in the world. So yeah, that's kind of the big benefit. I think the challenge realistically is actually building that. Like, it sounds fine in principle, but it's very hard to take, particularly machine learning tasks, these gnarly, huge, non-deterministic operations, and distill them down to something that we could all do together to have consensus over them. And that's one of the things Gensyn's been working on for nearly 5 years now, is kind of solving that verification challenge. How do we take these machine learning tasks and distill them down into something that a chain can do together? I could go on forever about this. I think latency is another big problem, but maybe I'll stop there and hand over to Greg for his thoughts.
I mean, he pretty extensively covered, right? I mean, if you want to unlock true decentralization, you have to, develop techniques to overcome Sybil attacks. For us, really, unlocking, we looked at just the sheer amount of compute availability a single company or a single entity could have is, there's a limit, there's a bound, right? If you want to remove that bound, you have to be able to have a peer-to-peer mechanism where the access and permission or membership to the cluster doesn't require a permission, right? So, and the foundation for that is verification. I think Ben covered pretty well, and I think another challenge is data. How do you really access the data that's locked up in different silos, if you think about it? And third is how do you really access to the models? I mean, if you have to rely on a single company to develop these models, you're not really tapping into the power of the crowd. And in order to tap into the power of the crowd, there needs to be some way to monetize the power, right? So in addition to compute power, I think the data and the access to that, the hive mind is a challenge.
I have to admit, you guys both have jumped my gun and literally, took my questions out. But that's what happens when you have people who know what they're doing and you give them a bunch of questions that we can discuss. So the way I was thinking is, like, given you both described how you both saw this, Ben, you kind of described this as a challenge of actually having, achieving consensus, and Greg, you kind of described it as more or less like unlocking the other three pieces. Like, I was literally going to go back and say, the question which I had in mind was, I believe now there's a thesis that the unusual effectiveness of data is no longer a valid thing, and I wanted to bring that as a discussion point after this. But then, now that you've jumped the gun, I will probably come back to that straight up to you back. So now, if I were to say this to you, given the state of affairs in Gen AI, there is this zero-shot learning where you almost have the situation where one could almost say, I'm not saying that's the case, the thesis of unusual effectiveness of data, which is like one of the very early papers that Jeff Dean and the rest of the guys came out, and the three things that you literally mentioned. For you to have an ARB in the machine learning world, you have three pieces. You have a human, or whatever that is, that actually does the model, the hardware on which you run the shit, and then, that data, right? So now back to you. Now that you said it, do you really believe that's the case? And in the case of decentralized AI, do you think the question of data being the limiting factor still exists?
Absolutely. I think most of the data, if you look at it, is in devices that are owned by people, right? And it's extremely hard to get the more sensitive the data, the harder it gets to get, right? For example, if you want to do medical diagnosis, how do you access data to even train a system, high quality data to train a system without breaking privacy barriers? And I personally wouldn't be comfortable giving, my medical data or my diagnosis to a system that doesn't guarantee the privacy, right? So and you can extend that to financial data. You can extend it to pretty much any type of data that has any degree of privacy, right? How do you really unlock? How do you really get? And decentralization is an answer. Now, I don't know what the solution is. I mean, I do know where we to look, right?
Yeah. I mean, again, this looks like we are jumping really ahead of the curve, and then you literally went to my next question. Sorry, guys. So, again, Ben, do you have any different thoughts? Because I want to follow this up with another question, and I would like to hear your thoughts on this and where you stand. And then I was thinking of proposing like a bunch of tools that exist as a cryptographer that I would see that we can actually solve, and I want you to give your take as two people who run decentralized AI protocols, your take on it, your personal take on it, how your protocol looks at it. But I would love to get your view first.
Sure, yeah. I think data, as you mentioned, there's like those three core components to any sort of machine learning system. People doing labeling and design of models, you've got data and you've got compute. And I think right now the most constrained resource is compute, but the other resources are also constrained. And so we release the constraints on compute and we just hit the constraints on the next one. And I think the machine learning space has been able to take the existing structured data that we have, that humanity's been curating for decades on the internet, and it's been able to compress that into these big models, and that's really effective. But that's just kind of like the first step. The next step in our view is, how do you make that live? How do you continually train models with live new data that we're all creating every day? We're all covered in sensors right now, like Apple Watches and phones and MacBooks and like Aura rings and all of these things. And that the data that comes from those devices is highly valuable, and it would be valuable in a kind of world model. But actually getting that data into the model needs certain kind of like technological rails. And as Greg mentioned, there's a bunch of like problems with that. Like privacy is a huge problem. And if you think, if we were to do this in the centralized world, privacy would be a huge problem because you'd be giving up access to that data to a company in order to do this. But if you think in the decentralized world, actually you could be distilling value in the data that you're creating into models locally. And then you would want to be able to use that to interact with models that sit not locally to you, that sit out there in the world. And for a single company to build the kind of infrastructure to do that, it's not really realistic. But if you build it as a protocol, it is realistic. You think that we all run TCP/IP on all of our devices, that's how they all talk to each other. You could have a similar thing doing computation between these chunks. So locally, you're distilling value in data into the models, and then you're talking to all these other pieces of models. So I think data remains incredibly valuable, but it requires similar protocols to the ones that we're building for compute.
So you're kind of alluding to some sort of a federated model kind of thing, right? So I just want to throw like a couple of things into the mix and make it a bit more interesting, given you overrun the gun in that sense of speaking. So like as somebody who had been tinkering with mechanisms to provide privacy, having worked on it for the last 20 odd years, typically the tools in the box you have is TEEs, trust execution environments. You have FHEs, fully homomorphic encryption. Then to prove things, ZK, right? So this is the tool that you have, plus the normal, gravy, which is, hash functions, symmetric crypto primitives, and asymmetric crypto primitives. If I were to give you this bucket, so I will give it to you first, Ben. What would be your first pick, and why you picked the first one? And you can go on from there and give to Greg.
Sure. So from our perspective, we like software. So software techniques are where we would index. TEs are interesting, but I think the limitations still hold. They're, in my view, a sort of like stopgap solution before we can have the equivalent from software, which is infinitely scalable. So we focus on that. And then the main kind of interaction we have with these technologies is particularly for verification. So zero knowledge techniques for verifying machine learning tasks is an area of research that we actively do. We have an interactive proof protocol that does a portion of the verification, but ultimately all of the techniques you mentioned aren't products themselves, in our view. They're just techniques to solve problems that you have when you build the real kind of product, the protocol itself. And so we design Gensyn using the techniques that we need, like the interactive proofs for verification, and agnostic and kind of open to the techniques we know will be needed in the future, like the privacy preserving techniques. So you think of submitting a machine learning task to Gensyn, we think about that as matrices. It's a bunch of matrices, you're doing matrix multiplications between them. We don't care necessarily whether that matrix is made up of ciphertext and is actually a lot of encrypted data, or whether it's obfuscated because it's already gone through a model and it's actually the embeddings of another model that you're running it on. We just care that you're doing some matrix multiplication. So our approach to it is be open and agnostic to those technologies to allow them to be used, and then apply the ones that we definitely need, like ZKML, ourselves when we need them.
Yeah, I mean, TEE has a big trust assumption on the hardware, and a hardware is susceptible to supply chain attacks. We saw famously what you could do with pagers, apparently. So yeah, hardware is, and TE is also very famously known for its vulnerabilities. And you see a 0 day every other day, right? So cryptographic is obviously our choice. I believe ZK is very, very promising, but it's still in a very nascent stage. It's very slow, and FHE is also well, FHE is TE based, so I don't think could be.
Yeah, I mean, it's interesting to hear from the people who actually built it. So I have my biases. I published a couple of papers on TEs like 15 years ago, 2007. That's 15 years ago, and I published a couple of papers in ZK in like last year or so. So I've seen both sides of the fence as a researcher, and I see the trade-offs. What I would jokingly say is like, ZK is in the same place where TE was 15 years ago.
Okay.
You know what I'm saying, the joke-wise, right? Like in terms of, okay, if I were to get somebody on the hot seat, say to them, this is what you have. Do I have a test vector? Do I have a library that actually is fully documented? Do I have all the curves covered? That's the kind of thing. That's where TE was like in 2007. Now ZK is coming there. We still use, largest amount of protocols still use growth 16. So, it's very used in. Let me go back to my next bit that I wanted to ask you about. So now that we talked about a bit of training, inference, and how things are going to be done, there's always this big question that exists, right? When you have ML, there's this question about biases, and there's also a question about explainability. So, Greg, this time you go first. What are your thoughts?
Well,
you can be brutal, okay? You don't have to hold anything.
Yeah, I mean, like, the challenge with current centralized models is we don't know what biases are trained on, right? So, like, famously, OpenAI, at least GPT-3.
Yeah, you can go back and quote the Microsoft one, the racist AI.
Which way back, right? That's like Sophia was the name of the model?
That's
it was trained on
centuries ago by AI terms, according to him out.
Right, and it changed. It became racist in like a day or two, it was trained on global data. Turns out people are racist on Twitter. Who knew? Anyway, so models' biases are as good as the data it gets fed, and the data it gets reinforced, right? So we saw famously what happened with the OpenAI GPT-3, where it was heavily biased because it was reinforced by people in San Francisco, and San Francisco tend to be a lot leaning on the leftist side, and also the Google AI Gemini. We saw famously how biased it is when you give it, to generate an image of founding fathers. It gives you, not Caucasian people. So it gets challenging. I think one of the reasons why decentralization needs to exist, more importantly, transparency needs to exist, is to understand these biases, right? So, that's pretty much what I have to say.
Ben, go for it.
Yeah, I think ultimately, like, the world is biased, right? Like, but the bias is everywhere. We all operate based on bias. Like, the fact that we're all individuals is because we're all biased, basically. And like, pretending that we're not would be ridiculous. Like, we kind of lean into that. There's value in that bias. And machine learning models, in many ways, are just like biased machines. We ask them questions and we want a biased answer, because otherwise we would just get like nothing from it, essentially. So the value is there, but the difficulty in the bad situation is if we constrain the bias that people have access to. So lean into the bias, accept that it exists, but allow a kind of free world of all of the biases to exist. And our view is that when you're using a machine learning model, when you're kind of running inference against a model, it should be up to you to choose the model that has the biases that reflect what you want in that moment. You shouldn't be constrained and only able to use a model that somebody else created and somebody else kind of fixed the bias in without having choice between them. And so the world we'd like to see is this world where if you're running like inference queries against a model and you say, hey, this model doesn't reflect the biases I wanted, you can then either switch to another model or you create the model that reflects the biases that you want. And from that, we end up in many ways kind of mimicking the like physical world and the biases that exist between people in the digital world. And I think that's a much more kind of equal situation than letting a single company or a small number of companies determine the biases that we all get to interact with. I think we're in a similar moment to where we were with social media before the kind of takeoff, where we didn't create social media as like an open protocol. We let it be captured by a small number of centralized companies. And what we've seen from that is they have outsized enormous control on what people think and what people see because they censor what people see. They censor what people say on social media and they skew what we all consume. We're at that same moment with machine learning, but even deeper. If we're going to outsource our thinking and our kind of logic process and our knowledge process to machines in a certain way, we can't let that happen again because it gets even deeper into people's brains, essentially. Like you're outsourcing a portion of your mind to a company rather than outsourcing a portion of your mind to something that you could create. So I think it's a dangerous time. We have the opportunity to choose whether we create the kind of early internet, the big open protocol, or whether we create social media again. And I think we create the early internet. I think we need to create this as an open system where if I don't like the biases of a model, I build another one. And anyone here could use it.
That pretty much ties into my next question for all of us. And this probably is going to be the more controversial one. I think it's not that controversial. So the question of governance, literally that's what you're talking about. So, I'm assuming both of you are familiar with both the failings and the good parts of the governance in the decentralized world. I would love for you, Ben, to start with. Share your thoughts on where we think from an AI ML perspective in a decentralized world. How good a fit are the current set of models? And do you see any new things over the horizon? Do you have any thoughts? Off you go.
Sure. I think the crypto world and the like decentralized world has spent a lot of time thinking about designing new governance protocols. I think personally, there's too much focus on trying to design those than sort of leaning into the emergence of the governance itself from real demand usage, because I think that's realistically where it comes from. You could say, like, if you take a new AI system and you say we're going to have direct democracy over the control of this system, chances are that's not going to work particularly well. We've seen many examples in the crypto space before where that doesn't work. It ends up getting captured because people lose interest. They, in the beginning, seem to be interested in governing, but later on they kind of forget about it and they don't do it. So realistically, what you want is everyone who's actually actively using a system needs to have some kind of governance say within it, and you want to kind of weight that governance by that usage in some way. But I think getting too rigid with the design of it is probably like the sort of failing or the kind of failure path that we could go down. It needs to be this sort of like almost like organic emergence in a way. That's a very dissatisfying answer because it basically says we can't design it right now. But I think realistically that is the case. We have to build these in as open a way as possible and then bring the governance in as we see the usage and see how people actually interact with the systems.
Yeah, the current system, current crypto governance. The current system is heavily, when we have proof of stake essentially as the primary way of crypto systems being governed today, is heavily focused on capital as the stake, but I think we definitely need to rethink some of these systems where the stake is not necessarily capital, but actual participation in the network, right? So fortunately, crypto gives us this tokenization mechanism where we can supposedly tokenize anything, right? You could tokenize usage, you could tokenize attention, or you can tokenize effectively, the contribution in some form. And systems should be governed by the people that use it, and people that have significantly higher involvement by using the system should have a higher say, right? And crypto gives us that foundation. Are we there yet? Now, Akash has seen quite a bit of. Akash has a completely open protocol. We have about 500 contributors that govern the system, that contribute to the system, and a lot more folks that actually vote on the system. And I think we had so far about 250 or so proposals that went through, and we learned quite a lot, right? So a big challenge is accountability, right? Like, so if you vote on something, because it's anonymous, there's no accountability for your actions. And that becomes very challenging because there's no recourse if you vote on a bad thing. In real life, when you have identity attached to your vote, you have some degree of recourse. And when there's no recourse, people tend to behave differently versus when there is some recourse.
I guess social media proves that to us, I guess.
Correct. So when you have identity tied to it, you act differently versus not. Now, is that a good thing or a bad thing? I don't know, right? Like, so people are just unpredictable. So it's very challenging to design truly decentralized governance systems. I think we are learning how to do it better by the day, but I think it's going to take a while to really understand and nail what works. But right now, it's very inefficient. There's a lot of wastage in the current governing systems, and
Thanks, Greg. So the thing is, like, now we have, like, I think 3 minutes. So we have a chance for the audience to ask questions. The gentleman over here. So put your hand up. Somebody will give you a mic. Say whatever you want to ask, and we see how these guys respond. You have a hand in the front.
Hello. Yeah, my question is like, as we know, like a normal normal people can store, like let's say 500 GB of hard disks they normally have. And in a decentralized, we are thinking to have multiple people are running the nodes and hosting the data. So because it is quite challenging the data chunking part and the gathering part, and because it's speed up. So what do you think, like how will be the data stored in the AI part as a more decentralized manner to be done? Because let's say if I want to run any model in general nowadays, I need a 16 GB RAM minimum, or let's say 250 GB hard disk. So those resources we don't get to come for normal people who wants doing those things. So how you do these challenges, we can pop up with that.
I don't understand. So can you?
What I understood is, forgive me if I misunderstood. It's like you are kind of describing what the state of affairs currently for machine learning model is, and what a typical machine typically would require. And you're kind of asking, number one, storage, right? So imagine you have X amount of storage. How do you expect that to be stored? Where then there's a decentralized infrastructure, number one. And number two is compute, when you have a minimal requirement of whatever the RAM and other constraints are, how that's going to be met. Is that right?
Yeah, correctly.
Correct.
So is that like the limitations of decentralization because of hardware constraints, basically? Like you have a minimum amount of storage required, you have a minimum amount of memory required, and that kind of limits the level of decentralization you can get to. Is that the kind of gist? If so, I think from my perspective, the limitations we currently see on hardware in those terms are set by the way that we do machine learning in the traditional space. So when you say, okay, Meta is going to train a new llama, they train a new llama in a very specific way, and it's kind of like recursive with the type of hardware that they have. So in many ways, Llama is designed for the hardware, and the hardware is designed for Llama, and there's this kind of like process of...
Wouldn't you blame that a bit more on the underlying hardware as well? So in my stupid head, it's like, okay, there's a bunch of hardware, it's a GPUs that's been built, then there's a bunch of libraries that's been built. Now all the libraries that have been built constrains the set of all skill set you can get. Now everything that's going to be built is going to be on top of it. So that's kind of an ARB that everybody gets.
Yeah, and I think we've been in that cycle for a while, but we can absolutely break out of that cycle as long as there's certain benefits to doing that. And from our perspective, the benefits are most kind of obviously price and scale. So the price to access this like very high-powered hardware and the ARB between that high-powered hardware and then that kind of cheaper but lower like capability hardware gets larger and larger to the point where actually it's beneficial to expand out to that kind of lower capability hardware. And I think that's the situation we're in on the price device side, although it's closed a little bit in recent years from the kind of centralized market. But then the bigger one is scale. Like Llama can be trained on a centralized data center, but what if you could train a model over every single device in the world? The scale would be far, far larger than the models we can build in a single data center, but you would have to deal with that kind of lower capability hardware. And our perspective is there's many ways to build machine learning models. The way that we do it right now is just the way that has worked for the past few years. It's not even that long. It's like 4 years that we've been building these like centralized large models. And it's time to expand that out. If we're going after scale, then we need to go after decentralization. We need to bring in that hardware that has lower capabilities, but you build a model in a different way. And it's perfectly, you can do that. It's perfectly possible.
Can I add one thing there? Yeah. Means in the Bitcoin, in the starting we running the Bitcoin miner in the like a P4 machine, and it mines the Bitcoin. And as we go and industry involved, we have the end miner specific hardware to running the Bitcoin mining. So do you think there will be the specific miners which specifically for decentralized AI DeepIn will be there, so which particularly do the mining for the model or do the particular thing rather than doing the CPU? Because generally in mining we don't need that much CPU power, so it do the CPU power layer and hardware power.
So I would say something, a generic observation. What you're pointing at is like looking at hardware that existed and how Bitcoin mining has evolved. It has become something like a European call option, right? So essentially you have some hardware, you vest it. So this applies, and you can think of machine learning processes as like a one-way function, a hash function. Loosely speaking, in the black box is a hash function. So you put something in, you have a result. If the result in the same bound, the question then goes back to what you are kind of alluding to. Can you actually have this competition of a set of all devices that's capable of doing? So per unit cost for doing a task, you're competing, for investment. So the temperature, ambient temperature where you're running the process, the cost for you to do one TPU operation or per cycle energy cost, plus the vesting or the sweating of the hardware that you already invested in becomes a key driver. Is that what you're kind of alluding to?
Yeah.
You're the gentleman, you should answer.
So from our perspective, I think what we're doing with machine learning hardware is essentially this refinement process from the base resource realistically, which is electricity. That's the kind of base resource of all of these things. And it's going through hardware that's translating electricity into machine learning operations. And what we would like for the world is the most efficient conversion, essentially. So we don't want huge overheads on top of what we're doing. We want it to get down to the most efficient, globally optimal way of doing this. Our position on that is that a free market is the best way of doing that. A free market should decide at what point a device is inefficient enough to just not be used for this. And that's what happened with Bitcoin mining, right? Like you went from general purpose devices to more efficient devices that were more efficient at converting electricity into
there
devices.
was a thing that was on top, which I think either one of you mentioned about consensus. And this is the thing that's currently missing as well. So it's like if you have two machine learning models running on two different things, there's no consensus mechanism sat on top to see which machine learning model is actually thrown out of the bin, right? That is not happening. So,
but also the hardware is getting specialized. We're seeing companies like ASICs taking center stage. A company called Grok that has really high performance ASICs for inference, and there are this new company that's building chips called Extropic, supposedly thermodynamic computing that's more specialized for machine learning. Like, I'll get into that. Yes, I think hardware does get specialized over time.
I think we are kind of running out of time. Sorry, guys. We've already run out of time. Thank you all very much. Thank you, Greg. Thank you, Ben.